So, next topic, previous session and previous class, we discussed chemical properties of metals. Now, let's discuss chemical properties of non-metals. So, we know what happens when metals reacts with oxygen, water, dilute acids, bases, chemical salts, chlorine and hydrogen. Now, let's understand chemical properties of non-metals. Chemical properties of non-metals. Chemical properties of non-metals. First one, reaction with oxygen. What happens when metals when non-metals react with react with oxygen. So when non-metal react with oxygen, it gives their respective non-metal oxide. So which are acidic in nature. So for example, when we burn sulfur, when you take sulfur, you deflate spoon and when you heat the sulfur, it gives fuels and it will transfer into the glass jar when you close the glass jar. Or simply, when we burn the sulfur, it gives sulfur dioxide. Which is acidic in nature. So when this sulfur dioxide is dissolved in water, so it forms sulfurous acid. Similarly, when carbon react with oxygen, it gives carbon dioxide. So this carbon dioxide is dissolved in water. It gives carbonic acid. Similarly, phosphorus, nitrogen also react with oxygen and forms their respective non-metal oxides, which are acidic in nature because they turn blue litmus into red litmus. So metals, these non-metals react with oxygen. They form their respective non-metal oxides, which are acidic in nature. Example: sulfur react with oxygen, gives sulfur dioxide. Carbon react with oxygen, gives us carbon dioxide. So non-metal react with oxygen to form acetic oxides and neutral oxides. The acetic oxides dissolves in water and forms acids. Carbonic acid, sulfurous acid is formed. A solution of sulfur dioxide in water, carbon dioxide, nitrogen dioxide turns blue litmus to red. So the reaction with oxygen, right, gives the reaction of non-metals with oxygen gives us non-metal oxides, which are acidic in nature. Their solutions of non-metal oxides turns blue litmus into red litmus. So these are acidic in nature. So here one activity is given in our textbook: burning of sulfur. Similarly, carbon dioxide, sulfur dioxide turn blue litmus solution red. We will now discuss some of non-metal oxides which are neutral, being neither acidic or basic. The neutral non-metal oxides they have no basic in nature, no acidic in nature. They are carbon monoxide, nitrogen monoxide, dinitrogen monoxide, or the Examples. Here, carbon monoxide, carbon monoxide, neutrality, nitrogen monoxide, nitrogen monoxide, then N2O, dinitrogen, dinitrogen oxide, dinitrogen oxide are the example for neutral non-metal oxide. Whereas water, hydrogen combined with oxygen gives us water. Gives us water. Gives us water. It is a neutral. Nothing but hydrogen oxide. Hydrogen oxide. Then water is actually hydrogen oxide. Note that non-metal oxides are formed by sharing of electron, so they are covalent compounds. We will discuss what are ionic compounds, what are covalent compounds later. Reaction of non-metals. So metals do not react. Metals do not react with water. Do not react with acids, because they did not displace hydrogen. Non-metals like carbon, sulfur, phosphorus are put into a test tube containing dilute sulfuric acid. Then no hydrogen gas is formed. No hydrogen gas is formed. Right. Then reaction of non-metals with salt solutions. Reaction of non-metals with salt solution. A more reactive non-metal displaces less reactive non-metal from its salt solution. A more non-reactive metal, more non-reactive non-metal displaces less reactive non-metal. For example, sodium bromide is reacts with chlorine, which is non-metal, gives us sodium chloride and bromine. Sodium chloride and bromine. In this displacement reaction, a more reactive non-metal like chlorine is displacing a less reactive non-metal bromine from its salt solution. Sodium bromide. So aqueous, a gas, and aqueous solution. Reaction with chlorine. When metals react with non-metals react with chlorine, they form their respective substances. Non-metals react with chlorine to form covalent compounds. So non-metals reacts with chlorine form covalent chlorides or covalent compounds. For example, hydrogen is a non-metal, chlorine gives hydrogen chloride, nothing but hydrochloric acid. Hydrogen chloride. Carbon reacts with chlorine gives carbon tetrachloride. Phosphorus right? Phosphorus also react with chlorine, gives phosphorus trichloride. So B4 phosphorus with chlorine gives us phosphorus trichloride. Phosphorus trichloride. B4. So here we then balance with the chemical equation. We can write 6. So non-metals interact with the chlorine form covalent chlorides. Covalent chlorides. So reaction of non-metals with hydrogen. What happens if non-metals react with hydrogen? They form their respective covalent hydrides. Form covalent hydrides. For example, hydrogen plus sulfur gives us hydrogen sulfide. Hydrogen sulfur is a covalent hydride. So it is hydrogen sulfide gives a smell like rotten egg. Rotten egg. Nitrogen. Similarly, nitrogen combined with hydrogen it gives ammonia. This ammonia is nitrogen hydride. Nitrogen hydride, which is called as ammonia. So balance the chemical equation we should write 6, 2. Then coming to the uses of metals and non-metals in our day-to-day life. We have so many uses of metals and non-metals in our day-to-day life. So let's discuss very simply. Metals are used for large number of purposes. Some of the uses: copper, aluminum metals are used to make wires to carry electric current because of they are very good conductors. Then iron, copper and aluminum metals are used to make household utensils and factory equipments. Iron is used in catalyst in preparation of ammonia gas by Haber's process. Zinc is used for galvanizing iron. Chromium and nickel metals are used for electroplating in the manufacture of stainless steel. Aluminum foils are used in the packing of medicines, cigarettes and food materials. Silver, gold, platinum are used in making jewelry. Then the liquid metal mercury is used in the thermometers. Sodium, titanium, zirconium metals are used in some atomic energy. Zirconium metal is used in making of bulletproof alloy steels. Lead metal is used in making of car batteries. So metals are playing a very important role in our daily life, right? So as we know very well, so that's why here I did not explain much about the uses of metals. Then coming to non-metals, one of the very important non-metals, oxygen. Right? Oxygen is a very essential for all living organisms. Nitrogen is also very important for plants. So in nitrogen fixation, right? Liquid hydrogen used as a fuel rockets. Carbon is used in making of electrodes of electrolytic cells and tricells. Nitrogen is used in the manufacture of ammonia, nitric acid and fertilizers. Due to its inertness, nitrogen is used in preserved food materials to avoid the ran acidity. So the chips packets, so the chips are filled in a packet, so in that the nitrogen gas is filled to avoid the ran acidity, spoiling of food. Compounds of nitrogen like trinitrotoluene. Compounds of nitrogen, trinitrotoluene, TNT, you can call it as TNT. trinitrotoluene and nitroglycerin are used as explosives. Sulfur is used for manufacturing sulfuric acid. Sulfur present in the hair, nails, eggs and onions. Sulfur used as a fungicide and making gunpowder. So sulfur used in making ointments, gunpowders, explosives, etc. And sulfur also is in vulcanization of rubber. Phosphorus is used in fertilizers. Oxygen, the very essential one. Right. Chlorine is used in disinfecting agent in bleaching powder. So carbon is used in purification of water. So many uses are there, metals and non-metals in our day-to-day life. So in examination point of view, right, do not write metals are used, non-metals are used for this purpose, that purpose. So write the particular name of the metal, like aluminum foils are used in making wraps or chocolates, biscuits, whatever. Silver foils are used in are wrapped around the sweets, right? Copper is used in metallic wires. Like that, mention the particular name of metal or the non-metal and write its use. That's the better thing. Instead of writing metals are used, non-metals are used. So answer is okay, but that answer is not interesting. So we completed the first part. What are metals, non-metals, alloys, physical properties of metals and non-metals, chemical properties of metals and non-metals, uses of metals and non-metals. Then the coming sessions we go to the second part about some electronic configuration and chemical bond, ionic bond and covalent. So thank you so much.